Download this code from codegive.com, link in the description below. Debugging an ESP32 can be a challenging task, especially for beginners. This guide will provide you with a comprehensive overview of various debugging techniques, tools, and code examples to help you effectively troubleshoot issues with your ESP32 projects. Table of Contents. 1. Understanding the ESP32. 2. Setting up the development environment. 3. Common debugging techniques. 4. Using serial debugging. 5. Using ESP32 exception handlers. 6. Using GDB, GNU debugger. 7. Debugging using freertos. 8. Monitoring memory usage. 9. Advanced debugging tools. 10. Conclusion. 1. Understanding the ESP32. The ESP32 is a powerful microcontroller with built-in Wi-Fi and Bluetooth capabilities. It is widely used in IoT applications. Understanding its architecture, including the dual-core processor and various peripherals, is crucial for effective debugging. 2. Setting up the development environment. Before debugging, ensure you have the following installed. Arduino IDE or Platform I/O, these are popular environments for programming the ESP32. ESP32 board package, install the ESP32 board definitions in your IDE. Drivers, make sure you have the appropriate USB drivers for your ESP32 board. 3. Common debugging techniques. Print debugging, use serial.print statements to output variable values and program flow. Check connections, ensure all hardware connections are correct. Watchdog timers, use watchdog timers to identify freezing issues. 4. Using serial debugging. Serial debugging is one of the simplest and most effective methods for debugging your ESP32. Example code ***. CPP. Include Arduino.h. Void setup. Serial.begin, 115,200. Serial.println, ESP32 debugging example. Void loop. Serial.print, current millis. Serial.println, millis. Delay, 1000. 5. Using ESP32 exception handlers. The ESP32 has built-in exception handling that can help identify critical errors. Example code ***. CPP. Include Arduino.h. Void handle exception. Serial.println, an exception occurred. Void setup. Serial.begin, 115,200. / enable exception handling. ESP_set_exception_handler, handle exception. Void loop. / deliberately cause an exception. Volatile int *p equals null pr. *p equals 42, / this will trigger an exception. 6. Using GDB, GNU debugger. For advanced debugging, you can use GDB with the ESP32. This requires a bit more setup. 1. Install GDB, ensure you have GDB installed on your system. 2. Use OpenOCD, set up OpenOCD to communicate with the ESP32. Example GDB commands * bash. Start GDB. Stensa ESP32 elf GDB your _firmware.elf. Connect to OpenOCD. GDB, target remote 3333. Set breakpoints. GDB, break setup. GDB, continue. 7. Debugging using freertos. The ESP32 runs freertos, which can be used for multitasking. Debugging multi-threaded applications can be tricky. Example code asterisk. CPP. Include Arduino.h. Void task 1, void asterisk PV parameters. While, true. Serial.println, task 1 running. V task delay, 1000/port tick underscore period underscore ms. Void task 2, void asterisk PV parameters. While, true. Serial.println, task 2 running. V task delay, 500/port tick underscore period underscore ms. Void setup. Serial.begin, 115,200. X task create, task 1, 1000, null, 1, null. X task create, task 2, 1000, null, 1, null. Void loop. / main loop does nothing. 8 monitoring memory usage. Memory issues can cause crashes or unexpected behavior. Monitor heap and stack memory usage using heap_4.c functions. Example code asterisk. CPP. Include Arduino.h. Include esp_system.h. Void setup. Serial.begin, 115,200. Void loop. Serial.print, free heap. Serial.println, esp_get_free_heap_size. Delay, 5000. 9 Advanced debugging tools. ESP-IDF Monitor, a tool that helps you monitor the serial output and logs from the esp32. esp32's esp-debug, a debugging tool that provides a graphical interface for debugging esp32 applications. 10 Conclusion. Debugging the esp32 involves a combination of techniques ranging from simple print statements to advanced debugging with GDB. By using the tools available and understanding the architecture, you can effectively troubleshoot and resolve issues in your esp32 projects. Always remember to check your code logic, hardware connections, and utilize the resources available in the community. With practice and experience, you'll become proficient in debugging your esp32 applications.